bald bearded builder, Michael Jolley. I'm a developer advocate at Vonage, where I get to play with cool APIs all day. You can find me at all these cool places on the interwebs. And today I want to talk to you about creating really cool interactive experiences using JavaScript, C++, facial tracking, IoT, maybe a little bit of the Vonage Video API. So without further ado, let's talk about Geppetto's Guide to Living Puppets. For those of you not familiar, Geppetto was the toy maker who created Pinocchio, who eventually turns into a real boy. Now, we're going to stop with the puppet, okay? But before we get into puppets, let's talk about communication on the web in general. You know, text is notoriously bad for communicating sentiment or tone. Just take this phrase, for instance. There's a big difference between "you want another piece of cake" or "you want another piece of cake," right? So one is going to gain you a friend. The other might cost you a friend. But it's okay. I mean, humans are great at adapting, and so they did. I'd like you to meet Alice. Alice, picture her. It's the mid-90s. She's dialed up to the internet. She's chatting with her friends. And then it happened. Those two keystrokes that will forever live in infamy. Parenthesis. Alice had found a way to express her happiness. And she and her friends started creating all of these little short codes for expressing their emotions. And it just blossomed from there. Today, we can't imagine life without emojis and animojis. We use them daily. They're just baked into almost every product we use. But now we've got machine learning and AI. And wouldn't it be interesting to see how we could advance this? You may have even seen some demos about sentiment analysis. Sometimes it's based on text, sometimes perhaps facial recognition. But what if we could take that data and manipulate physical objects with those same systems? You know where I'm going. Let's build a puppet. First up is designing the system. We're going to have two sides to this. There's the device side, and then there's the web side. Because, I'm not going to control this with levers and buttons. I'm too lazy for that. I just want it to watch me and do something. First, let's talk about the device side. We'll have servo motors inside the puppet's head, one attached to each eyelid, and then one to the mouth. For those of you keeping track at home, that's 3 servo motors. We'll connect those servo motors to a particle argon. The argon is really cool because it has Wi-Fi baked in, so we can make calls to it directly. All we have to do is connect it to our Wi-Fi and register it with the particle cloud. On that particle device, we're going to register webhooks with the particle cloud so that we can, from anywhere, hit those webhooks to dispatch events on the device to blink the left eye, the right eye, or open the mouth. Now, on the website, we're going to create an express application with the Vonage Video API that will create a single user video session. We'll track your facial movements on that video frame with TensorFlow, except we won't. So I started using Face Mesh with TensorFlow originally, and it really does a good job of tracking your face and tracking your mouth. It even tracks where your eyes are, but it doesn't give me the detail we'll need to know whether my eyes are open or not. For instance, look at this picture. It's tracking my mouth dead on, my face is dead on. It even knows where my eyes are, or should be, but notice my eyes are closed. It thinks my eyes are wide open. It's really not tracking whether it's open or not. It's just tracking the positioning. I need more detail than that. So we're going to switch up to the BRF v5 JavaScript library. It adds that kind of tracking built in so we don't have to do any additional work. With that, based on those points, we'll calculate whether you're blinking or not and whether your mouth is open or not. when we identify a blink or we identify your mouth is open, we'll call a fetch to trigger one of those webhooks on the particle cloud, which then gets sent down to the device. So let's look at the code on the device. We don't need a whole lot. We're going to use the particle argon. We're going to write it in C++. And you'll see here, we're going to create some default values here. These are basically the pin locations that control each of these. So the left eyebrow is controlled by D2. Then we're going to create some kind of radiuses, if you will, of the opening of the servo. You'll have to dial these in yourself if you try to build this yourself. For instance, like a left eyebrow open and closed state, that means, turn the servo to this position in a closed state or this position in an open state. That can vary based on your servo and positioning and how you've hooked it up. So you'll have to dial each of those numbers in yourself. Once we have those set up, then we'll create in our setup method, we'll attach to those servos right there. And then we'll call out to Particle Cloud and say, listen, we're going to register 4 functions with you. We want it called left blink, right blink, blink, and mouth. Blink just means both eyes went. Once you do that, then call the init method. So with that, we've attached to those servos so we can control them. And we've told Particle, we need to know about these webhooks. And when they call, let me know. And when I know, I'm going to call those functions. I'm registering callbacks, essentially. In that init, all we're doing is setting an initial state for the puppet. So when we turn this on, we want the puppet, no matter what state he's in, to open both eyes and close the mouth. It just brings us back to a good neutral so that we can start playing. And play we shall. So once we do that, we need to initialize our individual callback methods. Now, the clock's kind of running, right? So I don't have a lot of time to go through each of these methods, but they're essentially all the same. For instance, left blink, all I'm doing is telling that servo, write the closed state and then delay 1/4 second. Then write the open state, which is going to simulate a blink, right? All Particle Cloud functions require something to be returned. So I'm just returning 0 because what does it matter? This right blink, the blink, and the mouth, all those methods are exactly the same, only they're calling their appropriate servo with the appropriate states. For instance, the mouth won't go closed first, it'll go open first, then mouth closed. So once that's done, we are finished with the device side. If we were to plug the puppet in right now, it could receive webhooks from Particle, and based on those webhooks, it would open and close eyelids and mouths. Yeah. So let's move to the website. I'm going to really condense the website. I'm not going to show you every line of code on the website because, the web gonna web, lots of code there. We're going to look at just a little bit of HTML that matters. We've got a div with publisher. We built div city in VS Code. In this case, there's only one. We've got a video tag called webcam, and we've got a canvas called image data, _image data. That's important. Remember that name. Then in our JavaScript, we are starting up a camera. Now, this BRVFV5 manager, I've newed up that class already. It's kind of irrelevant to the talk. It takes in parameters like how many faces do you want to track? 1. What video tag should I use to watch? The one called video, that sort of thing. Doesn't matter. But what does matter is we're going to call get faces on that. That will find every identified face that it has got. And then we're going to go through those, which hopefully there's only one, and just draw little circles. That actually happens to be light blue. We'll draw little blue circles all over the face where every point that it identifies, including the eyebrows and the mouth. That's just mainly to make sure that we know we're tracking correctly. They don't really do anything. It's just for me to know that I've turned on tracking and it's working. This is another thing we're going to get with those landmarks that it finds. We know that landmarks, say 36, 39, 37, 38, 41, 40 there, those represent the marks around the left eye. These represent the ones around the right eye. These represent the ones, there's a lot more of them, around the mouth. So we just want to identify those specific landmarks that we're paying attention to. It's providing us a lot more landmarks. We don't care about those. So we're pulling out the ones we want to pay attention to because we'll use those later to detect stuff. So let's do that. Let's detect blinks. I created a method called detect blink, appropriately named. It takes in those 6 eye points. You'll notice eye outer corner, eye inner corner, eye upper lid, inner outer lid, upper lid, all them inners and outers of lids. Then it also takes eyelid distances. That'll be important. We'll talk about that in a minute. But we pass in all those parameters to that method. Notice that method was kind of agnostic as to whether it was left or right. It just needs to know certain points. We also define 2 arrays. These are the left and right eye distances that we've recorded previously. For instance, if I track your face right now and I identify that these distances of where things are, those points, I need to keep that for a few frames because you may not know this, blinks are fast. So I need to know relatively, are you still blinking? Are you now opening back up? Are you just eyes closed, full on, staying that way? So we kind of know whether we should trigger a new webhook or not, right? If you start to blink and we register, hey, they're blinking, send the blink, that next frame is probably going to still have your eye closed. We want to kind of know that we've already done that. Those arrays, when we get into the actual method of detect blink, we're going to do some math. I know, I'm sorry, it's disgusting. But in this case, pretty important. We're going to track certain things with those points that we provided. First being the eye width. Now, why do I need to know the width of the eye? Very simply, let's think about how cameras and distance work. If I get further away from the camera in front of me right now, you'll notice the width between this point and this point decreases. If I get closer to the camera, the distance from here to here increases pixel-wise. And we're going by pixels here, right? So we need to know that distance to realize the ratio to up and down. So what may look like an eye being closed may mean you're just standing far back from the camera, or something looking open may just be you're up close to the camera. So that distance in pixels is skewed by that. So knowing that width lets me determine what kind of ratio I should use as far as measuring the top of my eyelid and the bottom and their closeness. So once we do that, we're going to calculate our lid distance from each other on the outside and the inside of the eyelid, and then compare that with the eye width to come up with basically a distance that we're going to track. That 2 is kind of special to this math that you might have to dial that in yourself, but that's what that is. Once we have those distances, we're going to push those into that array of eye distances that we had. So if this is the left eye, we're going to push this distance into that array, the left eye array. If it was the right eye, we'd push it into the right eye array. And then we only want to keep the last 13. That's a little less than half a second of data, which if you're doing like 50 frame or 30 frames a second, that's about half those frames, right? So while distances are greater than 13, we're going to shift out the first one. So we're always keeping the last 13 distances, and we'll compare those to know whether a blink has started or eye close has started, really, and whether we should trigger those webhooks. So now that we have those 13 distances, we're going to group those into segments. We're going to take like the first 3, the last 3, and the middle 3, and we're going to compare those. We're going to round them up. We're going to create segment 0 through 2 because we love zero-based indexes. Get just those points we want, and then divide them by 3 to get an average of distance over those 9 sets of frames. Once we have that, it's time for math-a-go-go. The calculation here just calculates and compares the distances over that 13 recorded instances, and essentially really the 9 recorded segmented. It's ensuring that the distances are consistent with a close, like it's closing over time, versus like opening now or has been closed. And once we detect that over this span of 13 frames, essentially, we have steadily begun closing. And once we have that, we know that you are starting to blink or close your eye. We return a true. On that true, we are going to call webhooks, but we'll get to that. We're going to talk first about detecting the opening mouth. Detecting an open mouth is a little bit different. We need to actually, instead of returning like a true or false, we have to kind of play with it and just come up with a factor. So that's what we do. We've got just a open mouth factor, mouth open factor, that's between 0 and 1. And we get the vertices of the face, and particularly the mouth, but we're really watching the points here and here. The point right in the middle and watching those distances. We get that distance and we just send that back. We just send back the factor. We're not calculating in this mouth, or in this method, in this mouth. We're not calculating in this method whether your mouth is open. We're just returning that factor back out to decide somewhere else. And once the code comes up here, mouth open factor equals detect open mouth. We're passing in the vertices of our face. And if the mouth open factor is greater than 2, this is something you might have to dial in yourself, depending on most facial features. Faces seem to be working with 2. But there's a potential that you might not need to change that. So once we do that, we'll know the mouth's open, call the webhook. To do that, I created a simple send webhook method that just does a fetch, passes in a access token to Particle that calls a specific device in the Particle cloud and says, you notice we pass in a parameter called endpoint up there. That's because depending on what event we fired, we'll just call send webhook, left blink, right blink, or mouth. And that's actually passing along the endpoint webhook that we want to hit at Particle. And all it's going to do is send a post. Doesn't need a payload. We just send post, I blink, post to the URL with right blink or mouth. And that will get passed down to our devices. Yeah. Finally, I want to see what's going on. So when I'm in my video session in the browser, I want to see those points on my face. I want to see that it's tracking correctly. And I want to know that, even though you're drawing those little blue dots all over my face, I want to know that you know that I blinked, or you know that my mouth is open. So when I do know that, I'm going to change those dots colors to white. I didn't put that in here, but I'm telling you, just know. And in this case, we're going to add in the Vonage Video API piece. So one of the things I want to do is allow other people to join in and watch. Join into my session and see the little blue dots and see how it works. So I'm going to add in this code. It's going to watch that image data canvas that I told you about to begin with, that I said, remember? Did you remember? I knew you wouldn't. I told you. Anyway, we're going to watch that canvas and publish the stream from the canvas. When we're watching the camera and doing the facial tracking, we're taking the camera frames plus the dots we've drawn and putting that all onto this canvas of image data, and that's what we're publishing out on the web for other people to see and for us to see as well. With that, let's build something. I know what you're thinking. You've just melted my brain with all this code. There was so much of the maths. I know, I had to write it. I wrote it. I didn't want to see it again. But fear not, we are done with that mean old JavaScript. And now it's time to play with our toys. So, let me introduce you to Io, my puppet. Now, what you don't know is that this video that I'm in is actually coming from a web browser using the Vonage Video API. I'm streaming it into this presentation. And then I'm filtering out a green screen behind me. I know, believe it or not, I'm not standing in front of a piece of granite. Spoiled the illusion. I apologize. On the other side of that green screen, I've got this ugly looking guy. But he's excited. He's excited to perform for you. So we're going to make the monkey dance. So let me turn on the tracking in the browser that is showing up here. And like magic, you should see the facial tracking on my face. Now I talk a lot, so his mouth stays open a lot. But as you see me blink and talk, you'll see him move and blink. I have to give him time to close his mouth because he's like, this guy won't shut up, right? So you can see here what it's tracking, what it's identifying as far as my mouth being open too much, just ask my wife, or my eyes blinking. And based on those events, it's actually right now making web calls out, webhooks to particle sending them back behind me to that Argon that is making the monkey dance. You done? Oh. You done now? You good? Okay. Let's proceed. So, how practical is it to have an animatronic puppet? Okay, not really. But it's fun to build, right? And that's the best part of being a developer, is having these maybe weird ideas and getting to bring them to life. And what I hope you take away from today is that with all of these APIs, whether it's the Vonage APIs or Azure, AWS, there's so many out there. The only limiting factor in what you do with them is what you can think of. So I just want to really encourage you to build. Get out there and build. You do you, boo. Thanks so much for listening. I hope you found this talk informative and fun. Again, you can reach me on Twitter or all these platforms, and I am so thankful that you joined me. So with that, I am going to wrap it up and take your questions. Thank you.
Thank you for that brilliant talk, Michael, and thank you for sharing your beardiness with us and enlightening us all on the puppets that you've all been working with. So I'm going to dive straight into the questions here. Would TensorFlow be something that you could integrate into this project with a little bit of effort?
Yeah, absolutely. So I'm a little bit lazy in that regard. I just want to take a library that exists and plug it in. But if I was to like play with face mesh, you could probably change it a little bit to track the links. If I looked hard enough, there's probably already a library out there. Everyone's so great in the community to come up with all these different models and things. So it's very possible that with just a couple hours, you could have that working with TensorFlow.
Okay. And is that your puppet that we can see in the background there?
It is. Yeah. He's not plugged in. But he's there to scare off my kids. If they try to come into the office, I just shake him at them. And they go running.
He's got arms, and I assume.
Oh yeah,
legs.
he's got arms that you can stick your arms in. He's got legs that are in the closet. I have to clip those on. Yeah, there's a lot more things in that regard we're going to play with.
So, I mean, how realistic would it be to make a full body copying puppet?
I think you could. The legs would be difficult for this one because his legs aren't legs that you can put your legs into. They just kind of hang off of him. But arm-wise, you could build something for that. One of the things I want to do is add in, right now he's just got like a straight pole going up his body and into his head. I'd like to break that pole apart and put a couple servos in there so that he could tilt left and right and forwards and backwards so that he can mimic as I move my head, he does the same. He's also got servos. I didn't mention it, but he's got servos in his eyes to control left and right and up and down, so we can actually look around. But I don't have time to do all of it. That's in the hour-long session.
Around the room as you move.
Oh, that would be great.
It's funny you mentioned that because people often think conference talks are short, or like I'm pretty particular, and I'm like, let's get to the point, tell your story, and get off the stage so we can get as many cool, creative people on the stage as possible. So the talks pretty much at HalfStack are mostly 30 minutes or less, with a couple exceptions today, because we want you to like tell a story and like leave people wanting more to come back for the next one and learn what else there is to do with it. So I'm glad you mentioned that.
Yeah, absolutely.
Yeah, I'd be interested to see that. I think that would be a really good way to creep kids out to make the eyes follow around. And I'm sure there's a lot of people out there right now who would love to see that talk alone.
Could totally do it.
So are there any, if people want to dive into this kind of stuff, are there any pre-made puppets out there that people could use and play with that you would recommend?
If there are, I don't know about them. I actually had him made custom from a company called Luna's Puppets. I think they're out of Texas. And then just got with them on, okay, what exact, style of servo do you have powering the eyes, eyebrows, mouth, all that sort of stuff, so that I could, like, I think even on my desk, when we knew what kind of servo we were dealing with, I went and picked up the same servo so that I could test it just on my desk and get it just right without blowing those out. And then once I had them dialed in, it was just a matter of plugging in the pins and making the monkey dance.
You make it sound so easy.
It really isn't that hard. There's a lot of resources out there. The stuff with dealing with the particle argon boards. Particle has some really good documentation. It's some of the best I've seen. A lot of sample code. So I was able to, essentially, you're not going to find a demo for how to power a puppet, but you will find it for how to control a servo motor. So it's just a matter of, what do you want to do with it?
What do you see people doing with this? Like, what are the sort of real life situations where people might want a fully copying puppet?
Joe, are you suggesting you don't want a fully copying puppet?
I'm not sure.
So yeah, that's not really practical. But there are some use cases for that kind of technology overall. For instance, you could use the same sort of thing for people with disabilities who, maybe a paraplegic who has not a lot of control in their life. You could use the same kind of technology to watch their facial movements and turn their TV on or off or change channels, that sort of thing. That little bit of freedom for them means a lot. We kind of take it for granted. Another one would be like even like the Fukushima reactor in Japan that we can't go into, no one can go into and won't be able to for a long time. They're sending robots into that right now. So it gives another opportunity to control with maybe a little more precision those robots. If they're able to watch your face and as you look right, the camera pans right, that sort of stuff, instead of using a joystick or whatever.
That would be really cool. I think it feeds back to one of the sessions earlier today about the user interface, having to mesh around users rather than anything else.
Exactly, yeah.
So you seem like a very interesting guy, and you've obviously got one side project, which is a load of fun. Have you been working on anything else while you've been in lockdown, or have you been filling your time with non-techie things?
No, I appreciate that compliment, but don't believe the hype. Yeah. The only other project IoT related I've been working on is like I've got vegetable planter boxes out back. So I'm building little bird houses to sit on those planter boxes, and those are connected to like solenoid valves to my water and connected to moisture sensors. So, and those are using particle boards as well. They've got little LEDs. So like when they sense the moisture, the LED turns on. I'm using Chirp.io to like make little bird sounds. So like every time it comes on and checks the moisture, it sounds like the puppet is in the house, or the bird is in the house, like checking the water or whatever. And then it turns on water. So it's really nice aesthetic when I'm sitting on my back porch and, you hear bird chirps, just throughout the garden, and then you realize they're not real.
Nice.
You're not tempted to make it just shout, "Feed me, Seymour."
Yeah, exactly. That's a great idea. That's a really good. That would scare my kids too. I'm loving this.
Nice.
So Martin's asked a question on the chat, which actually I wanted to know as well while you were talking. How does the particle argon that you were using compare to the Feather Hussar 32?
I think they're very comparable. That's probably one of the best comparisons is comparing art particle boards to feather boards. The only thing that I would say in the difference is the particle documentation for me has been a lot better. The community and forums and that sort of stuff has been a lot easier to work with. And then also, I think the game changer, I don't know, it's probably a strong term, for Particle is their Particle Cloud that allows you to kind of manage those devices and send things like these webhooks to them. They integrate really well with like Azure's IoT Hub if you want to send telemetry up there and kind of keep it in some kind of database. So they you know, device-wise, very comparable.
Okay, I'm going to loop back to our previous question and try and find out what you're growing in your garden, because that's what I've been doing for the last couple of weeks.
Oh, yeah.
Building
So-
mine up.
We've got several like herbs, you know, cilantro and basil. We've got some cucumbers, some tomatoes, some peppers. I can't keep up with it. I plant what the wife tells me to, you know, I'd have to go bring her in. And
It's nice to hear that you've got a similar setup for gardening as me. My girlfriend just points at a patch and says, "Clear that."
that's right. That's right.
And it magically clears.
Here are all these little sprouts to go drop in the ground. That's okay.
We just grow scorpions and rocks in Arizona, so gardening's super easy. Just kidding.
Slightly more dangerous than a
A
tomato
little
patch.
bit, yeah.
That's true. Yeah.
Awesome. Well, thank you so much, Michael. That was an amazing session, and thanks for answering all of our questions, and we'll see you soon.
Yeah. Thanks for having me.
Thank you.
Enjoyed it.
Okay.